This is lesson 6.2, properties of similar figures. There are two videos for this, part one, part two. Please make sure you watch both. You'll be able to define and apply properties of similar figures to solve problems. A set of similar figures are literally dilated figures, okay? So figures that have undergone a dilation. In some cases, you're going to have to prove that a set of triangles is similar. And in some cases, you'll be asked to prove, you'll be told that you'll be given information that they are similar, and you'll have to find the scale factor. And we're going to be dealing primarily today with finding the scale factor for this video and determining what sides are proportional to what. And that's going to be what the IXL unit you're doing today is, okay? So the first thing you're doing, the first section, is a try it yourself. You are doing that by yourself. You are going to read the prompt. You're going to respond to the prompt. And I'm going to be coming around to check your responses as you write them down. Next is, so please take a second. No, it won't take you a second. It'll take you about 2 minutes to think it through, write down a response. Make sure it's thoughtful. So you're going to pause the video here and do that. Once you've returned, you're back, you're finished writing that response, you are going to look at section 2, which is properties of similar figures. This is super, super important. Do not skip past this section and just write down stuff because it's not going to help you in the least, okay? Now, I'm going to teach you how to identify what figures, or rather what sides correspond with what, and what angles correspond with what angles, right? So we have triangle ABC, right? We're given the information that, like I said, we're given this information that these two triangles are similar to each other. That means that this triangle was dilated and increased, or it could mean that this triangle was dilated and shrunk down. We don't know which one is the pre-image and which one is the image, and it doesn't matter, okay? Now, how to find corresponding sides and exactly what are they? Corresponding sides are literally sides in the same location in different figures. So for example, side AB in this triangle is in the same location as side DE in this one. That's what makes these correspond to each other. The word correspond is really important, okay? And so that's why I marked it in blue. I color-coded these. The two corresponding sides are in blue. And as you can see, side BC corresponds with side EF in the second triangle. Why? Because it's in the same location. And of course, the same with AC and DF. Angles as well. Angle A is in the same location as angle D in these two dilated figures. Same with angle B. It's in the same location as angle E. And that's the case with C and F. But what will happen sometimes is they'll give you the two triangles. They'll tell you that they are similar. And one of the triangles will be turned in such a way where it's really challenging for you to identify what side corresponds with what. And that's where this notation comes in very handy. Okay? It's very, very important for you to understand that you can use this to determine what corresponds with what. What do I mean by that? Let's talk about the angles, okay? So if I'm trying to figure out, just based on this information alone, say they don't even give us a diagram, right? I can look at the way that they order the vertices in the triangle to determine what corresponds with what. For example, angle A is written first when naming the triangle, and so is angle D when naming the dilated triangle. So that means that these two are corresponding angles. And as we can see, that is the case. They both are marked in pink. Angle B is next, and in the lettering here, it corresponds. It's the second letter in the naming of this triangle. E is the second letter in the naming of this triangle, and therefore, B and E are corresponding angles. Same thing with C and F. It's the third vertex that's named in this naming of this triangle. It's the third in this one. Therefore, they are corresponding angles. Same with the sides. Side AB corresponds with side DE. Side AB corresponds with side DE. Side BC corresponds with side EF. Side BC corresponds with side EF. Side AC corresponds with side DF. Side AC corresponds with side DF. Really pay close attention to the naming of your similar figures. That will help you a lot, okay? Especially in the IXL unit that you're going to be doing after this. Okay, on to the next thing. So we're going to make some statements about angles and statements about sides as it pertains to similar figures. So these are properties of similar figures. Okay, so if you have proven, or if they give you the information that says, yes, these two sides are, or rather these two triangles are similar, then you know for a fact that their corresponding angles are congruent. I'll say that again. If it's stated or given that your triangles in question are similar, then it is to be understood and assumed that their angles are congruent to each other. They are corresponding angles. And we just talked about what it means for angles to be corresponding. Not so with the sides. And it's pretty clear and easy to understand why. Just because these are similar doesn't mean the sides are congruent. And you can see that corresponding side AB and DE have different lengths. I actually measured them with a ruler. And so for, I'll just show you how I did that. You know, I measured side AB, it's 1 inch. And then I measured side CD, or rather ED, and that's 2 inches, about. Okay, I kind of rounded a little bit, estimated. Okay, so clearly they're not the same length, right? They don't even look the same length, okay? So in that situation, whenever we're dealing with similar triangles, if they're proven to be similar, or if we get a statement that they are similar, their sides are in proportion to each other. And that proportion is the scale factor. What do I mean by that? So let's take a look at these statements. AB over DE. That's what we mean by proportionality. So if you take, right, side AB over DE, right, that's their relationship, that they're proportional. Okay, they have a proportional relationship. Now if I take AB, which is 1 over 2, that means that my scale factor is a half. Okay, so that means I took this 2, right, and I applied it in such a way that I took half of 2, which is 1, and applied it to that side. Okay, so that is essentially, and once you have the scale factor, it's always going to be the same for every single side or set of sides in these triangles, okay? What do I mean by that? Once you have determined that your scale factor is a half, then your scale factor is a half for all of the sides in similar triangles. So we have a scale factor of 1 to 2 here. Doesn't mean that, it means that that's going to be the case for side AC, that their fraction is also going to be 1/2, or it's going to reduce or simplify to 1/2. And the same thing with BC and EF, okay? That's super duper duper important that you understand. Once we know that triangles are similar, their sides are in proportion to each other, they are proportional, and all of their corresponding interior angles are congruent to each other. Stay tuned for video 2.